Anna from NHCSR here. As an entomologist working in vegetable crop production, I find myself a little bit behind the ball in understanding crop nutrition, soil amendments, fertilizers, things like that. So I can definitely understand how head spinning and how confusing this is. So I'm reading up on that right now, trying to work on some more resources for that. But in the meantime, I found a very cool paper. I want to do a little summary of it because I think it's so cool. It's from a special issue of the Journal of Economic Entomology, Insects as Feed and Fertilizer, Sustainable Solutions for Food Waste and Animal Production Practices. It is a very neat crossover. It's some work done by some folks who work in livestock, some entomologists. They acknowledge the funding came from the USDA's Grand Challenges Synergistic Project, so that makes perfect sense. You have some people working together who wouldn't normally work together. I also noticed a couple of my USDA colleagues on the authors list who are involved in all sorts of different aspects of insect husbandry, which is a real interest of mine right now. They rear lady beetles as biocontrols, and so they're often working on things that you wouldn't really think about: how to keep insects healthy, what to feed them, production systems, thinking about insects as livestock. Very cool stuff. So let's dive into the paper. So this paper is looking into the byproducts of both poultry and insect livestock. However, they do set the stage by introducing the idea that insect farming for animal feed or human consumption, there's some real promise here to offset some of the energetic barriers to providing food to a growing global population, also a population that is growing in demand for higher quality food, more protein, more beef and dairy. This is what happens when more people are doing better globally. Compared with conventional livestock, insect farming, it's a more environmentally friendly industry owing to a much lower demand for land and water. You can fit an insect colony in a very small footprint, lower greenhouse gas emissions. I guess that means that they're not farting and burping as much. Enhanced feed conversion efficiency. They'll eat pretty much anything. So most of these operations have a really small footprint. They can be maintained pretty easily with low labor needs. And like I say, they feed them pretty much anything, byproducts from the farm used to feed these insect colonies. All right, so they provide us a graphical abstract, which is kind of nice. A primary byproduct of insect rearing is insect frass. When I say frass, I think bug poop. What the authors describe is a mixture of excretia and molted skins, so poop and cast-off skins as the insects go through different stages of molting. This paper is a kind of proof of concept study because there isn't actually a bug poop fertilizer industry the same way there's a poultry fertilizer industry, or at least not yet. Here they're saying they're kind of laying the groundwork for this kind of thing by highlighting some of the potential benefits and potential challenges of using insect byproducts to offset synthetic fertilizers. They do this by comparing and contrasting mealworm bioproducts to a kind of industry standard for animal manure. This is the poultry industry. They're looking at physical properties, chemical properties, nutrient supply, so what that manure could offer to crops if applied to soils. They're also looking into heavy metals and some pathogens, so some pros and cons. The insect that they're looking at here is mealworms, or darkling beetles. I believe that mealworms got their common name because they can be pests of stored products, grains, so worms that eat meals. They'll find them in stored products. Historically, we have used mealworms for lots of different things. Food for animals, livestock, and for pets. You can buy these things at the pet store. I'm sure plenty of you who have chickens are feeding your chickens mealworms as snacks. And also for people, there's several parts of the world where you can find mealworms as snacks, crunchy, nutty mealworm snacks for people. It sounds like this beetle has also been used in biomedical research as a model organism. You see this happening a lot in different fields of research where you will see an insect used as a model organism. Think Drosophila melanogaster. It looks like there's work investigating gut microbiota and immunity. They're looking at how animals can tolerate foods that are infected with pathogens or parasites, how it affects their behavior, their nutrient cycling, overall health, and some mating preference stuff. Kind of cool. It's an animal that's very easy to rear. Sounds like they'll eat just about anything, including polystyrene. That's really interesting. Authors say we anticipate commercial production to increase because of the potential for disposing of unwanted waste. They estimate that a commercial facility can produce 632 kilograms of insect frass weekly, taking up to 1,400 kilograms of organic waste out of that waste system. So there's a lot of potential for growth here. All right, so the paper. Authors acquired mealworm manure, insect manure, from two different sources. One came from a colony used for research purposes. So the USDA research colony was fed 90% wheat bran and 10% dried diced potato cubes. The other source was from a commercial insect rearing company, that's Beta Hatch. They were also similarly fed wheat bran as a base diet, plus apple cores once a week. Very cute. The poultry manure came from two different commercial operations in Arkansas and North Carolina. This litter was a mix of the bedding that the flocks were kept in. This is pine wood shavings used as bedding, spilled feed, and the waste from flocks that both of them were fed a pretty standard diet, mostly corn and soybean meal, plus a little bit of meat and bone meal, poultry oil, and all sorts of things that they add to the diet, micronutrients for healthy chickens. So they measured a ton of stuff having to do with macronutrients, micronutrients. I won't show you the massive tables that they shared in the paper, but they did provide a principal component analysis to just make some broad assumptions about the different sources they were looking at. Interestingly, in the elemental analysis, the two insect manures were more similar to each other than the two poultry manures. I guess that makes sense because they were fed very similar diets. You see this cluster of orange dots and this cluster of green dots were the two insect manures, where the ones up here and the ones down there, those were the different poultry manures. They found the insect manures had more nitrogen and less potassium than poultry manures. Phosphorus varied depending on the source. Insect manure had lower micronutrients, but also had lower levels of potentially toxic elements like cadmium, chromium. This makes sense. Authors mentioned in their discussion that differences in elemental composition were likely due to inherent diet nutritive values used in rearing conditions, and this could vary depending on what mealworm colonies are fed. Makes sense. They looked at the usual suspects in terms of indicator microorganisms. These are the microorganisms that investigators use to indicate risk of foodborne illness. Authors kind of say none of the levels were of concern, but there was likely more risk in the commercial facility where colonies were fed a wet diet versus the research colony that was fed a very dry diet. Authors also mentioned that other work in this area test heat treatments on the microbiological quality and safety of resulting manures from that feedstock. There's some examples from black soldier fly systems. So going forward, this work certainly sets the stage for scaling up production and considerations for operations in different regions, different feedstocks. This certainly will be important if you see lots of different facilities springing up on farm or in different areas. We're starting to see definitions and allowances for the use of insect frass in agriculture making their way into regulations. We're starting to see this, especially from the National Organic Standard Board talking about this. So the next step looks like digging into field trials and actually using this stuff. Very fun, very exciting. So let me know what you think. Do you want to know more about this? Is this something, would you like to buy insect manure? Would you consider establishing and maintaining an insect colony on your property, either for your home garden or your farm? Is this interesting to you, or is it just kind of gross? All right, leave a comment, and thank you so much for listening.